Uses of dimension. Physics for everyone welcomes you. Let us learn uses of dimension. The first one, to convert a physical quantity from one system of units to another. Second, to check the dimensional correctness of a given physical equation. Third, to establish relations among various physical quantities. Finally, dimensional formula in terms of given physical quantities instead of m, l and t. First one, to convert a physical quantity from one system of units to another system of unit. This is based on the fact that the product of the numerical value n and its corresponding unit u is constant. That is, nu equals constants. n1 u1 equals n2 u2. n1 u1 is the first system of unit. n2 u2 is the second system of unit. Consider a physical quantity x which has a dimension a in mass, b in length, c in time. If the fundamental units in one systems are m1, l1 and t1 and the other systems are m2, l2 and t2 respectively, then we can write n1 m1 power a, l1 power b, t1 power c equals n2 m2 power a, l2 power b, t2 power c. Good. Let us see an example. Conversion of 1 Newton to 1 dyne. 1 Newton is the unit of force in SI system. 1 dyne is the unit of force in CGS system. Solution. The dimensional formula for force, dimension force equals mlt power minus 2. So n1 u1 equals n2 u2. n1 is the value of force in first system. u1 is the dimensional formula of force in the first system. n2 is the value of force in second system. u2 is the dimensional formula of force in second system. So let us substitute n1 m1 l1 t1 power minus 2, n2 m2 l2 t2 power minus 2. Here m1 is kg. In SI system, the unit of mass is kg, the unit of length is meter, the unit of time is second. Whereas in CGS system, the unit of mass is gram and length is centimeter and time is second. We have to remember this. So let us write n2 equals n1 times m1 l1 t1 power minus 2 divided by m2 l2 t2 power minus 2. So rearranging, n2 equals n1 m1 divided by m2, l1 divided by l2, t1 divided by t2 to the power minus 2. Let us substitute the values. n2 equals n1 is 1 dyne, then m1 is kilogram, m2 is gram, l1 is meter, l2 is centimeter, then t1 is second, t2 also second to the power of minus 2. Second cancel, 1 power minus 2 again 1. Kilogram can be written as 10 power 3 gram. Meter can be written as 10 power 2 meter. So kilogram becomes 10 power 3 gram. Meter becomes 10 power 2 centimeter. Now we are going to cancel the gram, centimeter, centimeter. So 10 power 3 multiplies 10 power 2, you get 10 power 5. So n2 is 5. So coming here, n1 is 1 Newton, u is Newton. Then n2, we found that n2 is 10 power 5 dyne. So 1 Newton equals 10 power 5 dyne. To check the dimensional correctness of a given physical equation, principle of homogeneity. If the dimension of each term on both sides are same, the equation is dimensionally correct. Otherwise, it is not correct. It is not physically correct equation. If the dimension of each term on both sides are same, the equation is dimensionally correct. Otherwise, it is not physically correct equation. A dimensionally correct equation may or may not be physically correct. A dimensionally wrong equation, definitely physically a wrong equation. Find the correct equation. 1. V equal to u plus at. Then second one, V equals u plus at square. We know that the first equation is a valid one. The second equation is an invalid one. That's what we are going to prove. Let us take the first one. V equals u plus at. Let us substitute the dimensional formula for each term here in this equation. V is Lt power minus 1. U, its velocity, Lt power minus 1. Acceleration is Lt power minus 2. Time is t. Lt power minus 2 and the t multiplies, we get Lt power minus 1. So, in this equation on both sides, each terms are having the same dimensional formula. So, Lt power minus 1, Lt power minus 1, Lt power 1. So, it is dimensionally correct. The above equation is dimensionally correct. Let us go for a second equation. V equals u plus at square. Let us substitute the dimensional formula. So, here the t square multiplies t power minus 2. The third term in this equation is having a dimension of length. So, each term on both sides of these equations are not having same dimensional formula. So, this is a dimensionally incorrect equation. When the equation is dimensionally incorrect, it is physically incorrect. To establish relations among the various physical quantities, if the physical quantity Q depends upon the quantities like Q1, Q2 and Q3, then Q is proportional to Q1, Q2 and Q3. Mathematically, we can write a proportionality equation, Q proportional to Q1 power A, Q2 power B, Q3 power C. So, let us have a proper equation. Q equals K times Q1 power A, Q2 power B, Q3 power C. Here K is a dimensionless constant. When the dimensional formula of Q, Q1, Q2 and Q3 are substituted, then according to the principle of homogeneity, the powers of M, L and T are made equal on both sides of the equation. From this, we can able to find the value of A, B and C. Let us see one example. Obtain an expression for the time period of a simple pendulum T. Here you have a simple pendulum. Good. We are going to find the time period. Let us make this bob to oscillate. Time taken for one oscillation is called time period. It goes to the right extreme and then it goes to the left extreme, then back to the mean position. This is called one oscillation. The time taken for this one oscillation is called time period. Let this time period depends on the first factor is the mass. The time period T may depends on the mass M. Second, the length of the pendulum L. Then third, the acceleration due to gravity G at that place. Solution. So, T proportional to M power A, L power B, G power C. Proper equation T equals K times M power A, L power B, G power C. Here K is the dimensionless constant. Let us substitute the dimensional formula of each term here. We get on the left hand side T power 1, on the right hand side M power A, L power B and for acceleration L T power minus 2 to the power C. Now, we are going to write the dimensional formula of time in terms of M and L. So, M power 0, L power 0, T power 1, anything power 0 is 1 equals M power A, right? Is there any M in other term? No, only one M is there, its power is A. We have written it. Then there are two L, okay, they have the powers B and C. So, when the bases are same, the power can be added. So, L power B plus C, then T power minus 2C. Now, we are going to find what are the values of A, B, C, correct? Let us find the value of A. A, M power A, here M power Z, 0. So, A is 0. When we compare the power of M, we find A equals 0. When we compare the power of T, right, we can say that minus 2C equals 1. Then we can say that C equals minus 1 by 2. And it is being substituted here in this equation. In the power of L, we have B plus C. B plus C. B minus 1 by 2, because we substituted C value, which is equal to, on the left hand side, L power 0. So it is 0. So B equals 1 by 2. So this is way we find the value of A, B, C. Solving, A equals 0, B equals 1 by 2 and C equals minus 1 by 2. So the required equation is T power K times root of L by G. The value of K is found by experiment. It's equal to 2 pi. So T equal to 2 pi root of L by G is the proper equation. Dimensional formula in terms of the given quantities instead of M, L and T. If the velocity v, force F and time t are chosen as the fundamental quantity, express the mass and energy in terms of v, F and t. Let us go with the first equation. The dimension of mass equals n times v power a, F power b and t power c. Let us substitute the value of dimension of mass m power 0, L power 0, t power 0 equals the velocity L t power minus 1 is the dimensional formula. For force it is m L t power minus 2. For time it is simply t. N doesn't have any dimensional formula. Then let us rearrange the equation. M power 1, L power 0, t power 0 equals, is there any m? Only one m is there. Its power is b, m power b. Is there any L? L here, L power a multiplies L power b. So we get L power a plus b. Here you have t power minus a multiplies t power minus 2b multiplies t power c. So we get t power minus a minus 2b plus c. Right? When we compare the power of m, what we get? A, b becomes 1. Right? Straight. B becomes 1. When b is 1, then a plus b equal to 0. Then a equals minus 1. Correct? Right. So here minus 1 is being substituted for a. So it will become plus 1. Then minus b substituted as 1, so it is become 2 plus c equals, on the left hand side the power of t is 0. So we can get c as plus 1. So b is 1, a is minus 1, c is 1. This is the way we solve the problem, and the final value b equals 1, a equals minus 1 and c equals 1. So the dimension of m is n times v power minus 1, f power 1 and t power 1. Dimension of m equals dimension v power minus 1 f t. This is the answer. Let us go for the second one. Dimension of e equals n times v power a, f power b and t power c. Dimension of energy is m power 1, L power 2, t power minus 2. On the right hand side, n doesn't have dimension. So dimension of velocity is L t power minus 1, force is m L t power minus 2 and t is t itself. So on the right hand side you get the same old equation in the previous case. In the left hand side you have a little change. We have the dimension of energy here, m power 1, L power 2, t power minus 2. Right? So m power b, L power a plus b, t power minus a minus 2b plus c. Now we can write that b equals 1. B equals 1. B equals 1. The power of m is compared, so b is 1. So this 1 is being substituted here in this value. So a plus 1 equals 2. So we can get a equals 1. Right. So here the a value is substituted minus 1 minus b value is substituted 2 plus c equals, on the left hand side the power of t is how much? Minus 2. So this minus 2 and this minus 2 is getting cancelled. So we get c equals 1. So a, b and c each equals 1. So the dimension of energy equals n time v power 1, f power 1 and t power 1. So dimension of E is dimension of VFT. Thank you, children.